9b, solving quadratic equations by factorization. In order to solve quadratic equations by factorization, you need to know something called the null factor law. Now, some textbooks call this the zero product rule, but whatever they call it, it means the same thing. Basically, what it says is if you're multiplying two things together and it's equal to zero, the only way this can happen in the universe is if one term, the first factor, which is a, equals 0, or the second factor, which is b, equals 0, or a and b both could be 0. But the key is one or the other has to be 0 in order to use this method. So let's look at our first example. In example 1, we have 2x times x minus 4. So our first factor is 2x, and our second factor is x minus 4. These are two things being multiplied together, and they're both equal to 0. So that tells us that either the first factor, 2x, must equal 0, or the second factor, x minus 4, must equal 0. So we set up two little equations, and now we solve each of these individual equations to find out our possible solution. So using our inverse order of operation, opposite of multiplying by 2 is dividing by 2, get x equals 0. And the opposite of subtracting 4 is adding 4, so we add 4 to each side of the problem, and I end up with x equals 4. So in solving example 1, x could be 0 or x could be 4. In example 2, we have x plus 3 as our first factor and 2x minus 5 as our second factor, and it's equal to 0. So that means we can use our null factor law. So we get x plus 3 equals 0. Solving that equation by subtracting 3 from each side, I get x equals negative 3. Or we could say that 2x minus 5 equals 0 using our inverse order of operations. We add 5 and then divide by 2, and we get x is equal to 5 halves. Example 1 and 2, our equation was already factored and already set equal to 0. That will not always happen. So here are the 5 steps you need to follow when solving by factoring. First, you must get one side equal to 0, or we cannot use our null factor law. Once you get it equal to 0, then you must factor the other side. You can use any factoring method that we've learned in the past, but remember that the x method always works. After you get it factored, then you can apply the null factor law by setting each individual factor equal to 0, and then using our inverse order of operations, solve those two small linear equations and get your solutions. And then last but not least, and please do not forget this, you'll need to check at least one of your solutions to make sure you did not make a mathematical mistake while solving the problem. I'm going to start by getting the equation equal to 0. Also remember that we're going to have to factorize. And in our last section we did about factorization, it works best if the x squared term is positive. So you want to choose a side that's going to give you a positive x squared term. So in this example here, I'm going to subtract 8 from each side, and that gives me equal to 0, and I notice my x squared is positive. So I'm going to factor this using any method you want. I'm going to choose to use the x method. And I quickly see that this factors to x plus 4 times x minus 2, and that's equal to 0. Using the null factor law, I'm going to set each of these individual factors equal to 0. So it gives us x plus 4 as our first factor equals 0, or x minus 2, our second factor, will also equal 0. Solving each of these using inverse order of operations, for my first factor I get x equals negative 4. In my second factor, I get x equals 2. So my solution to this quadratic equation is x equals negative 4 or x equals 2. My last step is to check at least one of these solutions. So I take my answer, and let's say x equals 2, and I plug that into my original equation and make sure that we get a true statement. The left side equals the right side. In this case, when I plugged in the 2, it does. Solve example 4. In order to get it equal to 0, I'm going to subtract 3x from each side and add 1 to each side. So I end up with the quadratic equation 2x squared minus 3x plus 1, which I'm going to solve by our x method, simplifying down each side. That becomes x minus 1 times 2x minus 1 equals 0. And then use the null factor law and set each of these individual factors equal to 0. and use our inverse order of operations to solve for x. And I find that x is equal to 1 or x is equal to -2. And then I check. So let's check, going back to the original equation, replacing every x with 1. And I find that 2 is equal to 2. So that one does check out. Now, what if you chose the other one? Now, this is the reason it doesn't matter which one you choose, but you can choose either one and check and see if it works out. Let's say I chose the 1/2 and I checked it. I would end up that 1/2 is equal to 1/2, so it does check out. Example 5, I notice my first step is to get one side equal to 0, so I just automatically add 13 to each side, and so I have it equal to 0. But then I realized, wait a second, this is not, I can't factor this. So I realized maybe I should have expanded first. So we need to get rid of the parentheses by expanding out. And I realized my mistake. Wait, my x squared term is negative. So we need to move everything to the other side of the equation, doing the opposite operation. So I have 0 is equal to x squared minus 8x minus 33, which I'm going to solve by using the x method, which gives me the two factors x plus 3 times x minus 11. Using our null factor rule, set each of those equal to 0. In solving the first one, I get x equals -3, and the second one, I get x equals 11. Then I check my work to see if that's true for my original equation. And it appears -3 works. Now let's check the 11. And yes, it works as well. Showed example 6 is a lot of students will see that two factors on the left hand side and set them equal to 0, but you can't do that because our equation is not set equal to 0 here. So, and what I learned from my last section, it helps me first to expand this out before I start getting one side equal to 0. So I'm going to use a full method and expand out these two factors on the left hand side first, then I'll worry about getting it set equal to 0. 8x squared term is positive, I need to move everything to the left-hand side in order to set it equal to 0 by subtracting the 13 and adding the x. Combining like terms, we end up with the quadratic equation 8x squared minus 14x minus 15, which I can now factor. I will choose to use the x method to factor this. And it factors as 4x plus 3 times 2x minus 5 equals 0. Now using the null factor law, set each of these individual factors equal to 0 and use our inverse order of operations and isolate the x and get the x by itself. I get x is equal to -3/4 and x is equal to 5/2. Now all is left to do is to check my work. To check your work by substituting in your solution into the original equation. So in green, I'm going to check my first solution, -3/4. And I find that yes, it does work. Now I'm going to check my solution to 5/2 in blue. And I find that this one works as well. When you first look at example 7, you might be thinking, uh-oh, she made a mistake. Why is she putting this in solving quadratic equation by factoring? This is algebraic fractions that we learned in the last unit. But this actually is a quadratic equation. It's just hard to see it in this form. So what you'll need to do is first you'll need to cross multiply and get each equation simplified down. And then once you cross multiply, you will expand out. And you see, yes, this is a quadratic equation. Now, since my x squared term is positive, I'm going to move everything to the left-hand side by adding the 4x and subtracting the 36 and get it equal to 0. Combining like terms, we see that this is the quadratic equation, squared plus 9x minus 36, which I'm going to solve by using the x method. And after doing the x method, I see that this simplifies down or factors to x minus 3 times x plus 12. And using my null factor law, I'm going to set each of those factors equal to 0. And using inverse operation, I'm going to solve that, and I get x equals 3 and x equals negative 12. Now I can check my work, and you can check either one. Checking with the 3, I get an equal. Now checking with the negative 12, yes, it works as well.